4.3 trigonometric form of complex numbers. First, when we have a complex numbers, we have a real part, we have an imaginary part. We plot this imaginary number on a real and imaginary axis, just like we would on the XY axis. So if I have this imaginary number, 3 would be on the real axis. Imaginary is always my vertical axis. If I just had a 2i, so the 2i would be, my imaginary unit would be right here. It means it did not have a real part at all. So when I'm looking at this, when you're talking about absolute value always means distance away from 0. When we're talking about imaginary number, the distance away from 0, 0, right there, we have that right triangle that's created, or that's the same thing as kind of like our magnitude of our vectors. So we could take our real part and our imaginary part and square them and take the square root, and that would be our distance away from 0. So when we're talking about the absolute value of our imaginary number, that's always going to be the square root of a plus b, kind of like our magnitude. So if you look at example 1, first if I'm going to plot this, when you plot this, this would be my real part, and this is my imaginary part. My real part is -2, and my imaginary part is +5. 1, 2, 3, 4, 5. This is where that number would be. So to find its absolute value, I'm going to take the square root, making sure that this is in parentheses, of our real part squared plus our imaginary part squared, which is equal to the square root of 4 plus 25. So our absolute value would be the square root of 29. Now, let's bring the trig into it. Now, when I'm looking at the trig, and Z stands for our imaginary complex number. This should be similar for what you have seen in the last chapter. R stands for our magnitude. R stands for our magnitude. This is our real part, because our real part would be left and right. That's adjacent. Sine is our imaginary part, because that would be up and down. Because when we bring it back to trigonometry, which is just right triangles, that's our opposite. This is our adjacent. So when we're talking about a trig complex number, this is the format. And notice here too, because we're a value, it would be r times cosine, b is r times sine. So when I'm looking at this, we have our r value, our magnitude, right here, the absolute value, and then we still have this tan of our angle is b over a. Tan of our angle is b over a. That's the same thing as chapter 3. So let's look into that. So now let's try to write this in trigonometric form. So first thing I'm going to do is find my r value, our magnitude. So in this case, it's going to be the square root of -2 is our real part squared, plus -2 square root of 3 squared, because that's our real part, that's our imaginary part, which becomes a square root of 16, which is equal to 4. So that's our first step. Now we have to figure out what angle we're talking about, because we have this theta, that's our angle. So this is saying tan of our angle will be equal to our b value, which is -2 square root 3 over -2. First thing I notice that this is negative and negative. We know that this angle is in quadrant 3 because it's negative and negative. So it'd be a point right over here. So we're looking for this angle in that location. So if I simplify this, this is saying that tan of my angle is equal to the square root 3 over 1. That will help you find the reference angle. That's saying that my opposite is square root 3 and my adjacent is 1. So opposite square root 3 would be 60 degrees. So if this is 60 degrees, or pi over 3, this is 1 pi over 3, this is 2 pi over 3, 3 pi over 3, this right here is 4 pi over 3. So now I know my angle is equal to 4 pi over 3. So to put that all together, Z will be equal to my R value, which is 4, and then I have my cosine of my angle, so cosine of 4 pi over 3, plus my imaginary unit, sine of 4 pi over 3. And that right there is my final answer. So I want you to try to do the second one by yourself with first find the R. First find the R by yourself. So I have 2 square root 10. So now I'm going to look at my angle. Tan of my angle is equal to my b over a. So again, when I'm looking at this, I know it's in my first quadrant because it's 2 over 1, because this would be the point right there, my imaginary unit. Now in this case, I get 1/3. This is not going to be one of our special right triangles. If it's not a special right triangle, you can figure out this angle in your calculator. So I'm going to first make sure my mode is in degree. If you had this in radians, that's fine. I'm going to do it in degrees. So I'm going to go second tan of my fraction. So 18.43. So I'm going to leave it as 18.4. So my angle is equal to 18.4 degrees. So make sure you have a degree sign or a rad if you're doing it in radians. So z is going to be equal to 2 square root 10. And then we have cosine of 18.4 degrees plus I sine of 18.4 degrees. Bing, bada, boom. Okay, so now let's say what if we want to work backwards. Here's the trigonometric trig equation for my complex number. What's rated in standard form? So first, I would look at cosine and sine of 120. When I look at that, that's going to be in my second quadrant. This angle right here is 120. So my reference angle right there would be 180 minus 20 would be 60 degrees. That means my opposite would be square root 3, and my adjacent would be -1, and my hypotenuse is 2. So I'm looking at that number. I have 4 times cosine is -1 adjacent over hypotenuse plus I times opposite over adjacent or hypotenuse. Now I can distribute that 4 into both terms, and I would get that this is -2 plus √2 square root 3I. You can either have the I out in front or behind, it doesn't matter. Bing, boom, bam. So I want you to try to do example 5 by yourself. So because this is -pi/3, we're moving downwards, we're moving clockwise. So our reference triangle, our special right triangle opposite would be square root 3, because this again would be 60 degrees. So my cosine would be 1/2, and plus my sine, which is my opposite. In this case, it's -√3/2i. When I'm looking at this, I can simplify this root. This could be the same thing as 2 square root 2. You should always simplify when possible, especially in a problem like this, because when I multiply this in, then I'm going to be able to simplify. So when I multiply this in, just so you can see where that simplification comes from, I have this, and this becomes 2 times 1, a -1, give me a -2 here, square root 2 times square root 3. These two square roots can get multiplied. This becomes square root 6. And I have this 2 on bottom. Now I can simplify these 2's and these 2. Notice how I did not include the negative. So I'm going to have a square root 2 minus, I forgot my I here, sorry about that, an I square root 6. So last but not least, if for some reason we have a product of two complex numbers or a quotient, so multiplying or dividing, we would look at these two equations right here. If I'm multiplying, we multiply our magnitudes and we add our angles to get our product. If we are dividing, we divide our magnitudes and subtract our angles. So looking at this first one, if I'm going to multiply these two together, I'm going to have z1 times z2. We multiply magnitudes, so this would be 8 times 2. Sorry, I should have wrote the 2 first. And then in our parentheses, we're going to have cosine. Again, if it's multiplying, you're adding your two angles. So cosine of 120 plus 330. And then we're going to have an addition in between there. If you look, we have the addition between both of these, no matter what. This becomes I sine of 120 plus 330, just like that. And I simplify that. So this becomes 16. This is cosine. That angle, when I add those together, would be 450. So cosine 450 plus I of sine 450. I put too many parentheses in there. So if I want to find my reference angle of there, I have 16 times cosine of 90 plus I sine of 90. So when we're talking about 90, remember, that's this point right there. That point is 0, 1. Cosine is going to be my x-coordinate. So this becomes 16 of 0. That's cosine 90 plus sine of 90 is 1i. So if I multiply that 16 in, this is just 16i. So this is a pure imaginary number. Now if I look at the quotient, same type of thing here. We're going to do z1 divided by z2. So it's going to have 24 divided by 8. And then in our parentheses, cosine whatever comes on top. In this case, 5 pi over 3, subtract what was on bottom, 5 pi over 12. And we still have that I sine 5 pi over 3, subtract 5 pi over 12. And if you're not good at subtracting this, you can use your calculator to help you. You could do 5 divided by 3, subtract. Notice how I'm not including the pi with it. That's some fraction. Change that to a fraction. So we have 5/4 pi. So when I'm writing this, I have 24 divided by 8 is 3. This fraction here is 5/4, and this fraction is the same. Keep forgetting my I, fourths. So now I'm going to look at 5/4. If you need to always draw a reference, that's fine. This right here is 4 over 4. So right in this quadrant would be 5 pi over 4. So over 4, that means my reference angle is 45. So I have -1, 1, and square root 2. So this becomes 3 cosine, my adjacent is 1 over square root 2, plus my I value, my opposite is -1 I over square root 2. You have to multiply that in and rationalize it, which when I multiply that in, this becomes 3. And if I rationalize it, this would be 3 square root 2 over 2 minus, because of that negative right there, and 3 square root 2 I over 2. And that right there is my final answer. Have a great, have a grand, have a one day.